me, you are always welcome. You can ask me any doubt from light or human eye or anything. Okay. So, let us start from where we left in the previous class. Previous class we have learnt about electricity basics. I think Kritikeshwaran, if I am right, you are from LWA, isn't it?
Yes, sir.
This is the first physics class for you, right?
Yes, sir.
In your school they have taught electricity chapter, no? Electricity.
Sir, electricity and magnetic effects.
Yeah. So, here I have finished light and human eye and I am going to start electricity today. Okay. So, I
Okay, sir.
believe today whatever I teach will be going inside your head because you have already learnt about it. Let us see how much. But just because many of you were not there in the class, in the previous class, I am just giving a quick recap of whatever I have taught in the previous class. So, please pay attention to whatever I say now. So, in the previous class I said to you, the word electric current means flow of charges. Many people think that current is flow of electrons. It is not. Even if a proton starts to move, it has the capability of producing current. So, current means flow of charges. When I say the word charge, it includes both electron and proton. Difference is, when a proton is moving, the current is produced in the same direction of movement of proton, and if an electron is moving, then the current is produced in the opposite direction of the movement of electron. Then I told to you something about quantization, something which is not there in NCERT book. Quantization is a phenomena which says that net charge on a body is integral multiple of basic elementary charge. Now, what is the meaning of the word basic elementary charge? I said it to you that if you have a proton or if you have an electron, it carries some amount of charge. How much the charge was? Anybody knows this? If you have an electron or if you have a proton, what is the charge they have? Any idea? Anybody knows?
Sir, 1.6 into 10 to the power minus 19.
Great. So, 1.6 into 10 to the power minus 19 coulomb, I will write plus or minus. This is called as basic elementary charge. Meaning is, if you have one proton, this is the charge on the proton. If you have one electron, charge on electron. Then why I am putting plus or minus in front of it? To designate that it is produced by a proton or it is by an electron. So, somewhere if you see minus 1.6 to the power minus 19, it is indicating that it is the charge by an electron. If you see plus 1.6 to the power minus 19, it is the charge created by a proton. So, one electron or one proton has this much of charge. This is only called as basic elementary charge. Basic elementary charge. So, what is the meaning of basic elementary charge? It is the charge which is carried by one proton or one electron. Quantization says that net charge on a body Q is always an integral multiple of basic elementary charge. It means if you have 10 protons, then how much charge you have? 10 times this much. Common sense. One proton is having a charge of 1.6 10 to the power minus 19 coulomb. If you have 10 protons, 10 times of this value. If you have 100 protons, 100 times of this value. If you have 1 lakh protons, then 1 lakh times of this value will give total charge. I hope you get my point. So, total charge can be found by multiplying, what is n? N is integer, which is denoting number of charges. So, n is number of charges. So, when you multiply number of charges by basic elementary charge, what you get is total charge. I even told you in the board exam how the question will come from here. Question will come like a particular charge will be given and they will ask you, is this charge possible? For example, if I give you 3.2 into 10 to the power minus 17 coulomb, is it possible? Now, how will you check that? You have the value of Q known, you have the value of E known, find n. If n comes as an integer, it is possible. If n comes as a decimal, not possible. How you can have 1.2 protons? You can have 1 proton, you can have 2 proton. Can you have 1.6 proton? it is meaningless. So protons or electrons cannot exist in decimals. It can exist only in integers. So for example, this question if I give you, if you find n value, n will become equal to q by e. What is q given? 3.2 times 10 to the power minus 17. What is e? 1.6 times 10 to the power minus 19. This will make it 2 times. This will make it 10 to the power minus 2 times. It goes above, it will become 10 to the power 2. So 2 times of 10 to the power 2. Quite possible, 200. 200 is an integer, it's possible. But the same thing, if the question comes like, is a charge of 3.2 into 10 to the power minus 23 coulomb possible? You should check that. So when you do n will become 3.2 into 10 to the power minus 23 divided by 1.6 into 10 to the power minus 19. This will make it 2 times. This will make it 10 to the power minus 4 times, which will be 2 into 10 to the power minus 4. You should not see 2 and say it is possible. Minus 4 is there. It means 0.0002. Is it possible to have 0.0002 proton? No. So this charge itself is not possible. This kind of question has come in the board examination. They will give you a charge value and they may ask you, is this charge possible? That can be solved easily by dividing the given charge with basic elementary charge. This is the first thing I taught in the previous class. Then in the previous class I taught you what is the meaning of current, mathematical meaning of current. Theoretical meaning is flow of charges is current, but mathematical meaning is amount of charge flowing per unit time. It means rate of flow of charge, I is equal to Q by T. So when you multiply total charge by time, what is the meaning of time here? How much time it takes to cross the conductor. If 1000 electron moves from one part to another part in 10 seconds, then 1000 electrons, how much charge it will carry, you know? 1000 into 1.6 10 to the minus 19 divided by how much time it took. Suppose it took 2 seconds, divide by 2. That much will be the current produced. I hope you get my point. When you divide charge with time, what do you get? Current. Charge is in coulombs, time is in seconds. Coulomb by second is called as amperes. In the previous class I told you. So 1 coulomb is 1 ampere is 1 coulomb of charge flowing across a conductor in 1 second. In the board exam, this question also comes. Check your past year book. Question comes like, define 1 ampere of current. What should be our answer? If 1 coulomb of charge moves across a conductor in 1 second, then the current produced is 1 ampere. Then I taught to you the real meaning of the word potential difference. Many of you are really not aware about this word potential difference itself. Potential difference is the work done per unit charge. Potential difference given by the letter capital V, and I gave you the mathematical definition of it. Potential difference is what? Work done per unit charge to make it move from one point to another point. If you have a charge here, how much is the work done to make it to go from this point A to this point B? That will be called as the potential difference between A and B. So potential difference is work done per unit charge to move it from one point to another point. Work is in joules, charge is in coulombs. Joule per coulomb is also called as volts. Once again, they will ask you define 1 volt. If 1 joule of work is done to carry 1 coulomb of charge from one point to another point, the potential difference is 1 volt. All these things we have learnt in the previous class. Today we are going to proceed from there. I just recalled whatever I have taught in the previous class to you. Right? Let us start today's class. I hope everybody is ready. If yes, take the first question. Make it fast, don't take much time. The first question is in front of you, a very basic question, a current of 0.5 ampere. Don't write question now, don't waste time in writing the question, just write the answer. Don't spend time to write the question, just find the answer.
Sir, 180.
180.
180 coulomb.
180 coulomb, okay. Let us try. 180 coulomb is the answer by Nitin Raghav. Others? 300. Okay.
Sir, 1800, sorry.
1800.
Yeah, sir.
Let us check.
Zero.
0.
Sir, I left one cyber.
Okay, okay, no issues, no issues. Others, come with the answer fast. If you see properly, you will realize current is given, time is given, charge is asked. Simple question. I is equal to Q by T. I is known, T is known. Just multiply I and T, you will get Q. What is there in this question? If you multiply I and T, what you will get? You will get Q. So solve this fast.
5 coulomb.
5 coulomb is the answer by Kritikeshwaran. Kritikeshwaran, time should be in seconds. Don't forget that, okay?
Yes, sir, I am doing it.
Sir, I changed my answer, 300 coulombs.
Kritin Raghav, third time answer changing. In exam, you will not get 3 chances.
Sir, now I am sure, sir.
Sir,
No, I'm sure.
300 coulomb, sir.
Yeah, common sense. I is 0.5 multiplied by 10 minutes. 1 minute is having how much seconds? 60 seconds. So 60 into 10 is 600. 600 into half will become 300 only. Without even touching pen, you can say the answer. I is equal to Q by T. Q will become equal to I into T. I is 0.5. T is 600. 0.5 times 600 will be how much? 300. Half of 600 is how much? Yeah. Common sense. So that will be the answer for sure.
Sir, I did the calculations for 1 hour.
Wrong is wrong, Nitin. No justification of that.
Okay, sir. I will rectify.
What is this? How much work is done in moving a charge of 2 coulomb from a point at 118 volts to a point at 128 volts? Good question. Obviously subtract. Potential difference will be 10 volts. Answer is over now. 10 into 2, 20 will be the answer. Simple questions. In the last class I told you potential difference V is equal to what by what? W by Q. Just now before some time also I told you that potential difference V is equal to W by Q. Potential difference will be how much? 118 and 128. It will be 10. Q is given as how much? 2. 2 into 10 will be how much? That is the answer. Let us verify. If I am right, the answer will be, as I said, 20. Isn't it? 10 times 2, which is obviously 20. Next question you take. Simple questions, fast. Calculate the number of electrons constituting 1 coulomb of charge. How will you solve this? Just now I told the formula. Q is equal to NE. I told no. Q is known, E is known. Find the N. N also is given actually in the paragraph itself. Q is equal to NE. N will become equal to Q by E. Q is given as 1 coulomb. E is known to you 1.6 times 10 to the power minus 19. Divide, get the answer. Very basic question. Make it fast. N is? Yes. Q is 1. E is 1.6 times 10 to the power minus 19. Why are you writing this? This is not given. The second question. Yeah, or it is written, no? You are solving the first question, man. Huh. For teaching these things. First, you see the video that I have sent in the previous class. If you have doubt, you can ask me. I'll give extra class. I have already sent the recording of the previous class. Not saw that and came today. Okay, now here 1 week more time I am giving to you. See and get back to me if you have doubts. I will teach you. I am not saying I will not teach. I told just now, no, Q is equal to NE before some time the formula. Q is given as 1 coulomb. E I told you 1.6 10 to the minus 19. Divide both. You don't divide division, right? That's all. What is there in this question? I am not asking something hi-fi. Simple questions are there. This formula I told or not, Joshida? See here. This formula I told or not? I told no, Q is equal to NE. Q is given as 1 coulomb. So N will become equal to 1 by 1.6 minus 19. This division you cannot do. If you do, the same thing will come 6.25 10 power 18. That's all is the answer. This kind of question are like gift to you if it comes in the examination. Yeah, simple, no? Just division. Yeah, if you know division properly. If you don't know how to divide, then you should not be sitting in this class. For some people's help, you will struggle, I know. So the N value is equal to this 1 by 1.6 times 10 to the power minus 19. You will be wondering how I will divide this. Some of you will be there like that, I know. What you should do, see, this take it above, it will become 10 to the power 19. I can write like 10 times 10 to the power 18 divided by 1.6. Can I write like this? Now this was one more zero I will remove, it will become 100. So 100 by 16 times 10 to the power 18. Now it becomes simple. You can divide these two or not. 4 4s are 425. 4 6 are 24.10. 4 2s are 8. 20. 4 5s are 20. 6.25 10 to the power 18. Simple. I just taught you how to solve this division. If you are having problem in that also. Shall I go to the next question now? See, these kind of questions are going to be there in the exam also. What I am giving is very basic question. Try this question fast. Those who are struggling because of being absent in the last class, again I am repeating, whatever questions you are solving is based on 3 formula only. One formula is Q is equal to NE. One formula is, once again, I is equal to Q by T. And third formula is V is equal to W by Q. That's all. Whatever it may be. If it is 24, it's fine. Let me check that.
24.
Fine. That I am telling now, listen carefully. Q is charge. N is number of charged particles. Number of electron, number of proton is N. E is called as basic elementary charge. Yes, I told the value, no, just now. Magnitude is 1.6 times 10 to the power minus 19. I is current. Q is charge, I told you. T is time. V is potential difference. W is work. And Q is charge. So whatever questions we have solved, 3 questions before this, was based upon this only, no? Either this or this or this. Nothing we are going beyond that, because I have not taught beyond that in the previous class. Charge is equal to number of particles times basic elementary charge. Current is equal to charge by time. And potential difference is equal to work done per unit charge. That only we are solving. Okay, so got the answer 24. I hope you got the answer. Again, basic question, multiplication of 2 things. Very, very, very basic question. That's the answer. These questions don't expect in the exam to come. This much simple question. Next question you take. Fast. I hope from 9th you know that work done is same as energy. They both have same unit joules. In ninth, you have learnt about work, energy and power. Work is force times displacement, the unit is joule. Energy is capacity of doing work, that is also having same unit as joule. Got the answer? Got the answer? How much? 6 joule. Let us try to find that. Obviously 6 joule. Are you seeing how the questions are being asked? What are given today at least? Work is equal to V into Q. V is given as 6 volt. Q is given as 1 coulomb. Just multiply both, get the answer. How much energy is given to each coulomb? Each means what? 1. Q is given as 1. V is given as 6. Multiply both, you get work done, isn't it? And I told before some time, work done only is energy. Last question, I think, from here today. Solve it fast. Make it fast. Once again, formula based question. If you know the formula, you can answer it. sorry, yeah. So whatever questions, I think you got the answer, right, everybody? Very basic question, very basic question. So whatever questions I gave to you were very basic questions based upon three formula. Q is equal to NE, I is equal to Q by T, V is equal to W by Q. Let us start today's class. Give the heading as Ohm's law. So, please pay attention. Now we are talking about two quantities. In the previous class also, I tried to explain you the difference between current and voltage. From our childhood, because the way we are speaking about things around us, we get a wrong perception about potential difference and current. Basically, we don't know potential difference itself till we come in 10th standard. In your home, have you ever talked in terms of potential difference? Never. In your home, you will talk like current is not there, current came back. Do you ever talk like potential difference not there? I don't think, nobody. But the reality is, it's not the current that comes in the home. Like you think that from the point current is coming, right? General perception. If you have a point, current is there. I hope you believed like that only till now. Wherever you see a point, you think current is coming from that side. That's what a perception is. But last class I told you, it is not the current that comes from any point. From any point, only potential difference is there. So when you have 3 holes, 5 basically, anyhow 3 also, one is live, one is neutral, one is earth. Live is having 230 volt potential, neutral is having 0 volt potential. So the live and neutral creates a potential difference of 230 volt. Now why this potential difference needs to be created? Because only if there is a potential difference, the charges will flow, and only if charges will flow, current will be produced. Are you getting my point? So when I am connecting a switch, suppose a plug is connected, fan starts to run. Why? Because wires already have electrons that can run the fan, but that electrons are not moving in the same direction, that electrons are not creating current. But the moment you plug it there and you on it, what happens? There is a potential difference created. The potential difference created by the 3 points makes the charge to move in the wire, and that creates current, and with that current only the fan starts to operate. I hope you get my point. When I on this TV switches on. Why? Do you think that from that point electrons are coming? No, nothing is coming. That point is having one live wire, one neutral wire. Live wire is having 220 volts and neutral wire is having 0 volt. The moment I connect that plug inside, in the wire is made up of copper. Wire we have so many millions of electrons are there. Those electrons starts moving in one direction because of the creation of potential difference, and that creates current, and that current only is running this device. So never ever think that current comes from that point. What comes is potential difference. But our mistake from our childhood, we never talk in terms of voltage. We always say that current vandriche, current poiriche. That only we speak generally. So that is not current that is coming and going. Power comes and goes. And in each point we have potential difference. Your home, you are getting 220 volt. Government gives you 220 volt potential difference. If you go to commercial places, they will give 440 volts. If you go to railways, they are giving 20,000 volts. So that depends on the requirement, they are giving potential difference. More potential, you can consume more energy. If 440 volt is there, you can run 15-20 AC in your home. But now if you make 6-7 AC itself, your home will not be able to bear that. So that is different thing. Why we need more potential, less potential, that is different talk. But now in Ohm's law, Ohm was a scientist, a physicist, who made correlation between current and voltage. So he did an experiment. In that experiment, he made a circuit where he had a resistor, or why resistor, let me call it just a wire, and he had ammeter, a voltmeter. I hope you know what are those things. Voltmeter is to check the potential difference, ammeter to find the current. What he kept on doing, when he kept on changing the battery, first he put 1 volt battery, 2 volt battery, 3 volt battery, 4 volt battery. He found what is the reading of potential voltmeter and ammeter, and he plotted a tabular column for that. Then he made a graph. When he made a graph, he came to know that potential difference is proportional to current. We will understand in detail. Just write a definition now, definition of Ohm's law. So, write a definition first, I will give the definition to you. Definition says, potential difference across conductor, potential difference across a conductor, potential difference across a conductor is directly proportional, is directly proportional, is directly proportional to the current, flowing through the conductor at a constant temperature and physical condition, at constant temperature and physical condition. This at constant temperature and physical condition is very important word, because temperature will change, Ohm's law will not be valid. I will repeat the Ohm's law. Potential difference across a conductor is directly proportional to the current flowing through the conductor at constant temperature and physical condition. So, you can write after that, V is proportional to I. If you want to remove proportionality, you have to add a constant, right? All of you know this? That constant here is called as R. And what is this R? R is called as resistance. So, R is resistance. So, this resistance will become equal to V by I. V is in what? Volts. I is in what? Amperes. So, volt by ampere is called as, it has a name, it is called as ohm. Because of his name ohm, he gave it as ohm, the unit. It is represented by this symbol. This is a symbol of ohm. Ohm, O-H-M, ohm. So, once again, like how they may ask you define 1 ampere of current, define 1 volt of potential difference, they may ask you define 1 ohm of resistance. What will you define? How will you define it? It is the resistance across a conductor when 1 ampere of current flows by a potential difference of 1 volt. Write that also parallelly. Once you are done with writing this, you write a definition of 1 ohm resistance. If you are done writing this, write the definition of 1 ohm of resistance. I will repeat. Have you done that, written that on the board? What is written? If you have copied it, then define 1 ohm. 1 ohm is the resistance of a conductor. 1 ohm is the resistance of a conductor. 1 ohm is the resistance of a conductor when 1 ampere of current, when 1 ampere of current flows across it due to 1 volt potential difference, due to 1 volt potential difference. So, you have learned three things: 1 ampere definition, 1 volt definition, 1 ohm definition. Anything definitely will come in school examination. When this chapter will be there in the examination, they will ask you either define 1 ampere or define 1 volt or define 1 ohm, or all, maybe all three in the same exam. Important things. Okay. Now this resistance we learned in terms of Ohm's law, what is the meaning of that. But what is the literally meaning of the word resistance? Opposing. Like we say, I am resisting you. We will say no. That is Britishers were resisted by Indians. So resistance is something which is opposing. If you are opposing something, you are creating resistance towards it. Same way, please pay attention. Every conductor, every wire offers some resistance towards the flow of current. Every wire. How much a good wire it is. Sometimes we intentionally make resistors to make the current pass more slowly through it. So since the current is going to pass slowly, we give the symbol of resistance something like this. Symbol I am saying, resistor, like this. You know what it means? Like speed breaker. Current is coming, because coming here, it will slowly move. You may ask why? Sometimes we may need it. You know, we are needing current for heating effect. You may have iron box. How iron box is working? Plug in, it becomes hot. You are ironing it, isn't it? So what is there inside? A resistor is there inside. Resistor makes the current to pass slowly through it. Since it is passing slowly through it, it heats up. I hope you get my point. Like that, there are so many applications where we use real life resistors. When you go to higher class, you will learn how to make a resistor. Resistor we can make when we can manufacture. How to manufacture it, that you will learn. But now you can understand that resistor is a device which is resisting the flow of current. Now we are going to learn what are the factors on which resistance depends. So for that, let me, yes, here one thing they have shown, that resistance can come in any, like I told you, know, any conductor, it offers resistance. You know why it offers resistance? Resistance is opposition towards flow of current. Who gives that? Atoms inside the atom gives that. Atom inside the conductor. So if the charge is trying to move, if you have obstructions like this, what will happen? There is resistance. So if a particular element has more atoms, then it will give more resistance. So resistance in your mind you can establish like it is the hitting of electron when it is traveling in one direction. See, normally when you connect an electric field, these electrons will try to move in one direction. But if it goes and hits these atoms, right, particles. The more it hits, the more resistance will be there. So a densely populated conductor will have more resistor compared to a less dense conductor. I hope you get my point. Imagine I walk in middle of you. I will hit each of you and walk only. But if this room is free, I can easily walk through it. So if the room is filled with children, it has more resistance. If there are no children, it has less resistance. Think like that. So resistance caused by the density or the population of the atoms inside the element. Okay, this will be more clear to you when I tell to you about this thing, which is, see, write this point. The property of the conductor due to which it opposes the flow of current is called as resistance. If they ask you define resistance, this is the exact definition which will give you marks. The property of conductor due to which it opposes flow of current is called resistance. The property of the conductor due to which it opposes flow of current is called resistance. Now you can write, give the next heading as factors on which resistance depends. factors on which resistance depends. Factors on which resistance depends. We are going to learn about the factors now. Factors on which resistance depends. So basically there are 4 factors. The first factor is length, right? Length. The second factor is area of cross section. The third factor is material. You can write type of material. And the fourth factor is temperature. These are the 4 factors on which resistance of a material depends. I will explain one by one each thing to you, but write this, it is important question. The 4 factors on which resistance depends are, first one is length, second one is area of cross section, third one is material or type of material, and the fourth one is temperature. Okay. Let us understand in detail what are these. So for that, let me write the first thing. First thing you write length, and you can write there resistance is proportional to length. R is proportional to L, how it is mentioned here. R is proportional to L. It means that more the length, more the resistance, less the length, less the resistance. Okay, why it happens so? This is very common sense. If you have lesser length, we have lesser number of atoms. If you have a longer length, we have more number of atoms. And just now I told you, resistance depends upon the number of atoms. If more atoms, it will have more resistance. So a smaller length has a smaller resistance and a longer length has a larger resistance. That is why I write resistance is proportional to length. Second is area of cross section. Can you guess what will be that? Whether it will be proportional or written here. So R is inversely proportional to area of cross section. What does it mean? A bigger area of cross section will give lesser resistance and a smaller area of cross section will give more resistance. Again a common sense, it is very common sense. See, if you have a door and the line of people is hundreds of people are standing, what will happen? People cannot enter fast, but if the door becomes wider, more people can enter. You can imagine by that, if the wire is thicker, more electrons can flow through it, because the resistance will be less. But if the wire is thinner, then less current is flowing through it. Or you can understand like this also. If you have a smaller cross section, I'll draw it here. If you have a smaller cross section, okay, then the chance of an electron to collide is more compared to a bigger cross section, because now I have more space for the electrons to move, isn't it? Here the space of movement was less, here space of movement became more. So bigger cross section will have lesser resistance. Are you getting my point, what I am trying to say? So R is proportional to length, R is inversely proportional to area of cross section. It means R is proportional to L by A. If R is proportional to L by A, if I remove proportionality, I have to add a constant. That constant is called as resistivity, rho. Rho into L by A you can write. Rho into L by A, where rho is called as resistivity. Rho is called as resistivity. Resistivity will become equal to R into A by L, and from here you can get its unit also. Resistance is in ohm, area is in meter square, length is in meter, meter gets cancelled. So its resistance will be ohm meter, its unit will be, SI unit of resistivity will be ohm meter. Ohm meter. Now already there was a constant resistance, not constant, yeah, constant only obviously, but why did we bring this resistivity also in picture? See, please understand the concept of this. Suppose I want to classify the material based upon resistance. I want to classify materials, copper, aluminum, gold, silver. I want to classify them based upon resistance. Is it possible? Actually not possible, because if you have 1 meter of aluminum, if you have 2 meter of aluminum, they will have different resistance. So you cannot say that this much resistance, if it comes, it will be aluminum. This much resistance, if it comes, it will be copper. This much comes, it will be gold. We cannot say like that, because different length of aluminum will have different resistance. Different area of cross section will have different resistance, isn't it? A thicker gold wire, a thinner gold wire will have different resistance. But resistivity is not like that. Resistivity is a constant that came with this expression. So resistivity does not depend upon length and area of cross section. Write down somewhere. Resistivity does not depend upon length and area of cross section. Please make a note of it. Very important point. Resistivity does not depend. Resistivity does not depend on length and area of cross section. That's why we classify the materials based upon resistivity. That's why we classify the materials. That is why we classify the materials based upon its resistivity. Now if you want to classify, you can classify, because copper, aluminum, whether it is 1 meter of copper, 2 meter of copper or 1 kilometer of copper, its resistivity will be same. You have 1 centimeter square of copper, 1 meter square of copper or 1 millimeter square of copper, it will have same resistivity. So it does not matter whether you are having what cross section or what length. All materials will have, that is a single material will have single resistivity value only. But if you change the material itself, if I take aluminum and copper, they will have different resistivity. So resistivity does not depend upon length and area of friction, but it does definitely depends upon material and temperature. So if they ask you on what factor it depends upon material and temperature. This is the part from where you will have questions in the examination. Numericals will come from here. I will give some questions now, but you understand that what is resistance and what is resistivity. Please be very careful about that. Same thing what I told is given here. Okay. This yes. If a question comes like this, what will be the answer? On what factors does resistance of conductor depends? Length, area of cross section, material and that's all is the answer. The 4 factors. Okay, next question. How does resistance of wire change? Length is tripled, what will happen? It will also be common sense, yes. Diameter tripled. Solve this and tell me. Think, be careful, be very careful. B part is not as simple as you are thinking. B part is not as simple as you are thinking. It's diameter, not the area of cross section they have given. Be careful. If they have given area also, directly you can say the answer, but it is diameter given. It's a board question, I think. It has come in the board exam. What, Preetham?
Sir, 1 by 9.
1 by 9. Okay, let me check. Third part. 1 by 9 is correct? No idea.
1 by 36, I think.
For which one? Second part or third part?
Little one.
Third one.
I have to check, sir.
Please check. Let me solve it now. Please pay attention. Please pay attention. resistance is equal to rho into L by A. Am I right? Please pay attention, guys. They are asking you, how does resistance of a wire change when its length is tripled? They have given L dash becomes 3 times of L. There are two possibilities here. Length is tripled of the same wire, or whether length is tripled of a different wire. There are two possibilities, right? I am having a copper wire of 1 meter and I take another copper wire of 3 meter. It means length is tripled. It is also possible that there is a length of 1 meter and this wire is stretched and this wire is made long and now it became a 3 meter wire, isn't it? They both will be different, because if in this case length becomes triple, area will also reduce, isn't it? Conservation of volume. If this is the case, what you are saying is correct. If the material is remaining different, that is, there is a wire and there is another wire taken of same material, same area of cross section, but 3 times longer, then what you are saying is correct. L dash becomes 3L. So R dash will become equal to rho into L dash by A. So R dash will become equal to rho into 3L by A, which will become 3 times of rho into L by A. What is rho into L by A? R. So what will be R dash? 3R. R dash will become equal to 3R. So as you said, will be correct. But nowhere they have mentioned that length is tripled of a different wire. So what we should assume, until they not mention anything, we should assume that the same wire is elongated. If the length is increasing, area will reduce, right? So how to find that, how to solve that kind of question? New area will become equal to old area. What will be new area? Area of cross section into length. What is old volume? Area into length. Do you agree with me? L dash given as 3L. So A dash into 3L will become A into L. LL gets cancelled. A dash become equal to A by 3. It means if length is tripled, area will be 1/3. Now put in this expression. What will happen to R dash? R dash will become equal to rho into L dash is 3L. What is A dash? A by 3. Preetham, the answer is R dash is equal to 9 times of rho L by A, right? So R dash will become equal to 9 times of R, not 3 times. I hope you get my point. Don't expect the question to be that simple. I hope everybody is clear in this. I have used what? I have used the concept of conservation of volume. I hope everybody is aware about this. You have studied in math, right? Surface area and volume. A sphere becomes a cone becomes something. Not studied till now. They will teach it very soon. But this is common sense, right? If you have, please pay attention. If you have something, maybe you can imagine like a clay. Clay is there in spherical, ball shaped clay is there. The same clay you make into a cube. Do you think its volume will change? Its area will change, but volume will not change. If you make into a cone, if you make into a hexagonal structure, whatever you make, you can press and change the sides, but calculate the volume, it will remain same. Volume cannot be changed, no. You have some volume of substance, whatever shape you change, its volume will not change. So when you have a wire, in common sense says, if you stretch the wire, it will become thin. So longer the wire, thinner the wire. That's how this question is solved. Is it clear to you? Same way, when the diameter will be tripled, its area will also be changed. It will become less. If area is becoming more, length will become less. Common sense again. If this is the pen, I am stretching it. What will happen? It will become thinner, smaller. If I am elongating it, it will become thinner. So whenever the length is increasing, area is reducing. Whenever the area is reducing, length is increasing, or area is increasing, length is reducing, whatever it may be. In next class, we will talk further about it. We can solve this type of questions more, and it is important for the exam also. Meanwhile, today everybody is there in the class. Once again, I am repeating, the previous class video also you see properly, get the notes. This chapter is simple if you understand it carefully. Okay, we'll wind off now. We'll meet again in the next class. Bye bye. Take care. Don't forget about tomorrow's practice class.